Hey everyone, this is question number 72 from chapter 13. So this problem asks, what is the net force on each side of a box that contains air at atmospheric pressure and the box is closed and heated to 165 degrees Celsius? So the force on each side of the box is going to be equal to the pressure difference times the area, because we know that pressure is a force per area, and to solve for force, you multiply by area. So we need the difference between the pressure on the inside and the outside. Well, we know that the outside is just going to be 1 atmosphere, so now we need to solve for pressure on the inside. And we can use the ideal gas equation for that. So PV equals nRT. We're solving for, we need pressure, and we're given temperature, and we have volume. And we're going to assume that volume, number moles, and R, obviously the gas constant, is going to stay constant. So that's going to give us the relationship that P1 over T1 equals P2 over T2. Again, just because V, N, and R are going to stay constant. Okay, so then we can rearrange that and solve for P2. P2 equals P1 T2 over T1. Okay, so plug in values. P2 equals P1, 1 atmosphere, times T2, 273. Gotta convert to Kelvin, plus 165 over 273 plus 15. That's K. Plug that in and you get 15 to 1 atmospheres. Okay, so then we need to find the area of the side of the box. So area of one side is going to equal L squared, but we're just given volume of the box. So volume we know is length cubed. So to find the side of the length of one side, we can take L is going to equal V to the 1/3, or the cubed root of V. And then we're going to square length. So if you square length, we're going to get area equals V to the 2/3. So A equals 6.15 times 10 to the minus 2 meters to the 2/3, raise the power 2/3. Plug that into your calculator and you get 1.5581 times 10 to the minus 1 meters squared. Okay, so now we have our pressure difference, pressure on the outside, pressure on the inside, and we have our area. So now we can go ahead and solve for the force. So F equals, again, just to rewrite, delta P times A. So we have delta P is 0.521 atmospheres times area that we just found. Oh, excuse me, we have to convert to pascals. 1.013 times 10 to the 5th pascals. And then times the area, which is 1.5581 1 times 10 to the minus 1 meters squared. Okay, plug that into your calculator and you get F equals 8221 newtons, which we approximate to 8,200 newtons.